All right. I've had a few requests from people to solve some Sudokus on the channel here. And I've created quite a few Sudokus before and recently recorded some Sudoku videos for something else. And people asked me to do some here, so that's what I'm going to do today. I've just gone over to Logic Masters Germany, this site here, and I just basically went to the list of recent puzzles and looked for one that I thought sounded interesting. And Odd Tetris uh, jumped out at me. I thought, well, that sounds fun. I enjoy Tetris. It's been a while since I played Tetris, and it looks to be similar to Kropke. So we're gonna try this one out. So I'll include the F Puzzles link in the description below the video here if you want to give this a try. And right now I'm gonna give it a shot. So let's get to it. All right, so I've got the puzzle pulled up here in F Puzzles. Let's look at the rules. So normal Sudoku rules apply. You must fill the board, except for the given one in box 5, with Tetris pieces. The cells of each Tetris piece sum to an odd number. No digit can repeat in a Tetris piece. So I guess we can kind of think of the Tetris pieces like killer cages in that sense. So, but the sum has to be an odd number. So if this was a Tetris piece, the sum of these four would be an odd number, and no digits can repeat. Um, White circles show the difference between two adjacent cells in the same Tetris piece if their difference is odd. So between adjacent cells. Okay, so right, so these are all odd differences. So it's just showing this is just normal difference, but that means that the adjacent cells with the dot in between them have to be in the same piece, I guess. The black circles show that the ratio between two even digits is odd. So this is saying the ratio is odd. So that would have to be 1 to 3, right? Because, well, between two even digits, yeah, because the biggest difference you can have between two even digits is 2 to 8, and that's a ratio of 4. So the only even ratio would be 3. I mean 1 to 1, but you can't have a 1 to 1 because it'd have to be the same digit. And I think that means it's got to be 2 and 6, right? If they have to be even digits. This shows the ratio between two even digits is odd. So I think these have to be 2 and 6. Um, no circles span two Tetris pieces. Okay, so like I thought, the circle has to be within the same Tetris piece. All white and black circles within a Tetris piece are okay, which is why it says that makes more sense than I was confused before. This if their difference is odd part of it, I thought, well, all the differences given are odd. What is that? Of course, if the difference is odd, but the key thing is all the circles are given, so you can't have um, now an odd difference means the two digits are one odd and one even. So interesting. So basically, that means that, for example, if you had, well, that wouldn't work, but let's just say if this was a Tetris piece here, you couldn't have an odd and an even next to each other, or they'd need a white dot. Um, okay, so I wonder. Well, I mean, I can see right here because the circle can't go between different. I mean, this has to be a puzzle piece, or not a puzzle piece, a Tetris piece, because the dots can't be between two Tetris pieces. Um, Actually, those are all the same. These are all the same. We're gonna have to use a lot of colors. Fair warning, I am colorblind, so I'm gonna call a lot of these colors the wrong thing probably. So this one could be the blue or the yellow. This one has to connect to there, yeah, because this is already 4. Oh, and so that has to be that way, doesn't it? Let's go blue again. Oh, these are all a piece. I'm actually kind of surprised that I can get as much as I can with these. I figured the puzzle pieces would be hard to figure out. What red again? No, I don't want to use purple there. It's too similar to the blue for me, if that's even blue. Let's see. These are the same. Let's go red again. These are the same. Oh, and in fact, so this cell right here can't connect to the red or this gold color. So it must connect here, and then the only place it can pick up a fourth cell is right there. I'm assuming everyone's familiar with Tetris shapes, but basically they're all four cells. You have the four in a row that makes kind of a long, capital I. You've got the L shape that's 3 and 1, either direction. You've got the kind of Z or S shape, and then the T, kind of a squat fat T, and then just the box. This is a four square. This one has to connect over here, but then I guess it could come down or go over that way. I don't really know that. These two have to go together. Do red again. This one can't come over this way because it would have to keep going. These three are actually all together here. These three are all together. These two. Yeah, how about that color? Let's see, can we... Oh, so this yellow now, because of this gold down here, this yellow, the only place it can get a fourth cell is right there. So that has to be yellow, which is going to push the blue down. Now this yellow can't grab that one or it would have to take both. So this has to be yellow. No, not necessarily that one. These two have to be the same though. This could be part of that, or this could come down and this one could come this way. Well, this red, it could go here, but no matter what, it's going to have to take this cell. So we can make that one red. It could stick out here or come back that way. I don't think we know that yet. But this blue. These are the only other two, right? Because it can't connect there or here. Yeah, so it's got to take these two, which is going to push this red down here. We need to make this a different color now. Let's just go gray. There we go. Gray, which pushes this red this way. I got too much red in the middle there. Let's do this bluish color again. There we go. This one could be the red or the... Oh, no, it's got to be this yellow. Which puts this purpley color over here. This gold's got to come down and up that way then. Now that red... Oh, the red can't go here because these two have to be together. So the red's got to come out this way. These two are... I don't like that. Is that okay? Yeah. I'm not great with lots of colors. Actually, let's go gray again. Let's do another gray. I've only got the one gray over here. These two are the same, but we don't know. We don't know whether it comes up here or if it, goes down here or something or across that way. Don't really know. Now this one has to come up. It's the only thing it can connect to. But it doesn't have to connect to the gray. It could come up this way though. So I'm going to leave those. Okay, we're going to start over here and see what we can do with this. All right, so we have the 2, 6. So it has to be a difference of 3. So that is either 5, 3, or 9 with the 2, 6. This one is a difference of 5, so that's 1 or 7. Now, if these are even, these have to be odd. Can't be 1 because the one down here. Because if it's another... No, 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 no. I'm thinking about that backwards. It has to be another even, actually. Because if it's odd, it will have a white dot in between. So they have to be the same parity. Yes, same parity. Okay. Which means this also same parity. It must be a 4 and 8 to go with the 2, 6. 7 feels like it's going to be useful. So if the difference is 7, it's got to be 1, 2, 8, and 1, 8 or 2, 9. We've already used the 2, so it can't be 2, 9. So it has to be 1, 8. This is then going to be 2, 7, or 9. It can't be the 2, so it's 7 or 9, which makes this an 8 and a 1. We've got some digits. How about that? Now, this has to be the same parity, because again, it would need a white dot otherwise. 3, 5, 7, or 9. Oh, we've got same thing as the 7, 1 down here. We've got the same 7 and 1 up here. And in fact, it sees the 2, 6, just like the other one. So again, this has to be 1 and 8 with 7 or 9, right? Yeah, so this is 8 and 1, the same way. And this has to be odd, because they've got to be the same parity. Now 8 gives us the 4 down here. Now we've got all 4 of our even digits in the column, so this is an odd, which means this is an odd, which makes this an even, but it also has to be a difference of 5. It can't be an 8 because of this one. It also has to be a difference of 5. So this can't be 3 because there'd have to be an 8. This can't be 5. So it's 7 and 2 or 9 and 4, which gives us 5 or 7 down here to be 3 different from the 2 or the 4, because you also can't have 1. Which is interesting. I think that gives us a 7 in here either way, right? It's either 7, 2, 5, or it's 9, 4, 7. So either way, there's a 7 in one of these two. So this can't be 7. So we've got 7 in one of these. Let's see. Oh, our 3's here. So a digit can't repeat, right? No digit can repeat in a Tetris piece, right? So if we put, well, you can't put a 1 here anyways, but let's say we put a 2 here. These would both have to be 5. And then it would repeat in the same piece. So that's going to limit this. This would have to be, I mean, this is a minimum of 2. So this is going to be a minimum of 5. You could have 2, 5, 8. You could have 3, 6, 9. I think that's our only options. So these are either 2, 8 or 3, 9 with a 5 or a 6. So that makes this 4, 5, 6, 7. It can't be 7. Gotta have a, so down here in box 7, 4 is in one of these two, which means this can't be a 4. And that gives us a 5, 6 pair here, which makes this a 7 and a 9. Now you can't have 9. If you can't have 9, then you can't have 3 over here. 2, 3. Oh, and you already can't have an 8. So this is either 2, 5, 8 or 3, 6, 9. This can't be a 2 anymore. 2, 3. Oh, and the 5, 6. Yeah, it gives us 3, 2, 4. The 2 makes this 5 and 8 and 6. Remove the 3 down here. Okay, let's look. Oh, the 8 here. Yeah, 4. All right. And the 1 gives us a 7. So this is 2 and 6. There we go. Yeah, let's look over here. So we need 3, 6, and 9 in the row, and this row needs 1, 5, 7, and 8. This can't be 7 or 8. Now these are a difference of 1, and since there's no 2 down here, these can't be 1s up here. The 5 could go with the 6, 7 with 6, 8, 9. Now since there's no 2 or 4 up here, these can't be 3s. So this is a 3, which gives us a 2 or a 4 right there. Now this has to, well, if it was the same, we don't know. I was going to say this has to be the same parity, but that's only if they're the same Tetris piece, but this Tetris piece could go like that still. But we do know that these two are the same Tetris piece, and since they don't have a white dot, they have to be the same parity. So this is 1, 5, and 7. That puts an 8 over here. Well, we could have put an 8 over here anyways, because one of these is going to be a 9. One of these is a 5 or a 7. 3, 2, 4. Okay, what do we have here? 1, 3, 5, 9, I think. This one can't be a 1. These are all the same pair. So this has to be an even to match up because it has to be opposite parity since it has the dot in between. So 2 and 6 are already taken. So this has to be 4 or 8. That gets rid of the 1 there. It puts a 1 over here. 1. That gives us a 1 down here. Can't be there. 1 and 1 of these two. All right, I'm going to come back over here. We got another 7 dot in here. Those are helpful. So 1, 2, 8, or 9, we said. This can't be 1 or 8. This can't be 2. So 2 with 9 or 9 with... Oh, so this can't be 1 or 8. This has to be 9. 9 and 2. 6 and 8. Wow, that was helpful. 7. This is a 5. This is now a 9. This can't be 9. So what do we got left in here? We've got 2, 3, and 5, and this can't be 5. Well, partly because of the 5, but also because the 2, 3 tells, is the only option for consecutive digits. This is a 5. That makes this a 2 and a 6. This is a 7 because of that 9. We've got 3 and 4. Gives us a 1 there. 3, 4 there makes this either 6 or 7, because you can't go down to 1 from the 4 because of that 4. 6 or 7. 6 or 7 makes this, which is going to make this an even. No, not necessarily. No, because you could have 6. It could go 6 to 7. It can't go 6 down to 5, but it could go 6 to 7. But we know this is not a 1 no matter what, because it has to be consecutive to this. So this is either 7 or 8. It can't be a 5 or a 6 because of those. But it's not a 1, which gives us the 1 here. Now that 1 tells us, since there's no white dot, this has to be an odd. 3, 5, or 9. And again, no white dot, this has to be an odd. 3, 5, and 7, which tells us this has to be an even since it does have a white dot. So that's the 3. This is a 3 or a 5. This is 3. 6, 7. 3, 5. It puts a 7 here. It's the only place in the column for a 7. 3, 5, and 9. 3, 5, and 9. Yeah. 1, 1. 1's over here. All right, let's see. Let's look at this 5 here. So we can't have 1 and 6. Can't have 2 and 7. Could have 3 and 8 if it was this way. 4 and 9, is that possible? Yeah, 4 and 9 is still possible as well. This is going to be 3, 5, 7, 8, 9. Can't be 7. Yeah. 3, 4, 5, 8. There's got to be a 2 down here. Oh, and it can't be right there. So this is a 2. It makes this a 7. This is 6 or 8. This one, no white dot. It's got to be same parity. Can't be 2, 4, 6. So it's an 8. That means this can't be an 8, which means this can't be a 3. Now we have 4, 9 here. This can't be a 9 then. We've got a 4, 9 pair. 4, 9 means this is not a 9. This is a 3, 5 pair. The 8 here makes this a 6. 3 and 5 down here for the row. This 6 gives us the 9 up here, which gives us the 8. 6 with the 5 or a 7. These are opposite parity, so we can't... Oh, yeah, which means they can't be in the same Tetris piece because they don't have a white dot between them. So it's not a block up here. But that still doesn't tell us for sure whether this one goes across here. Oh, it does. Right, because this is even. There's no white dot. These two cannot be in the same Tetris piece. They'd have to have a white dot. So these two are part of that blue piece there across with here. These two cannot connect over there, so they have to come down this way, which means this is odd. 3, 5, 7. It can't be 7. It can't be 3. So now we've got a 1, 5, 7 triple here. It gives us a 2, 4 there. And again, these two can't be in the same Tetris piece because they have opposite parity. So the yellow must extend down here, making this an odd. Okay, now what else can we do? That means these 4, this must be another straight one over here, making this even. C is a 2 and a 6, so it's a 4 or an 8. Just making sure I didn't miss anything obvious with my pencil marks. I probably did, but not seeing. Oh, there we go. The 8 sees the 4 right there. Now I have a 1, 3, 5 triple, making this a 9. This has to be an odd. It sees a 1 and a 7, so 3, 5, or 9. 3, 5, 9 to complete the column. And it sees a 5, so that's not a 5. Oh, right back here. Same deal. This has to be the same parity because it's in the same piece. So this is a 3. 2. This can't be... Neither one of those can be 3 now. 5, 4, 8, 9. Yeah. Okay, 3 or 9 makes this... Oh. Actually makes that a 6 either way. Whether that's a 3 or a 9, this is a 6 because it has to have a difference of 3. That's interesting. Which makes this 5 or 7, and we already have a 7, so that gives us 5, gives us the 9 and the 8 and the 3, and a 5 up here, and 1 and 3. Now this can't be a 1. 2, 4. The 5, 7 pair gives us a 1 there. This 5 here makes that a 3. That 4 makes that an 8, and we're just missing 1 for the row. Okay, let's see. This gray now we know must extend over here. And I think that finishes off our Tetris pieces. Yeah. So this has to be the same parity. It's got to be an even. So 2 or 6. Let's see. What else do we need? We need 2, 5, and 6 to complete the row. This one can't be 6 because the 6 down here. Difference of 3. It can't be 1 and 4. Can't be 2 and 5. 3 and 6. 4 and 7. think are possible if we do it this way, because the 7 down here. Oh, 7 down here sees this up here. That's 5 and 7. That might help. So 4 and 7. Can we have 5 and 8? No. Can we have 6 and 9? No, we cannot. So this has to be 4 and 7. It's going to give us the 2 and the 4. This is missing 9 to complete the row. 2, 5, and 6. So this has to be the same parity since there's no white dot. It's got to be the 5, 2, 6. The 8 here. It has to be a difference of 1. It gives us the 9 and the 4. Right, what are we missing in the row here? We're missing 1, 4, and 8. There's a 1 and a 4 there. That's an 8. That makes this a 7 or a 9. And since there's already a 7, it's a 9. These can't be 8. This has to be the same parity as the 2 and the 8, or there'd be white dots in between. That makes that the 4. This is the 1. Difference of 1 means that's a 2 and a 3 and a 5. That gives us the 3, 5 over here. And I think it didn't stop the timer, but I think that I'm going to do highlight conflicts. It's going to give us a conflict. Ah, right. That's why it didn't stop the timer, because it thinks the black dots are normal ratio dots, and they're not. All right, so there you go. That was Odd Tetris by Kyle Watt. I thought it was pretty fun. It was interesting. I'm not sure that all of the clues were necessary. I feel like I wasn't using the fact that that there were I didn't feel like I used the pieces too much. I did a little bit with the ones that couldn't have white dots, but seemed like I got most of the pieces figured out at the beginning, and I'm not sure how much that helped, because some of those it made it easier to get, maybe the 3, 9 up here in the corner, the 3, because it had to be odd, but a lot of that I feel like probably would have been figured out from just normal Sudoku anyways, but that's okay. I'm fine with having multiple ways to solve a puzzle. It was fun. It had some interesting things with the, I'm used to doing crop key where it's just a difference of 1 and a ratio of 2, and this had lots of different differences, so just kind of thinking about that a different way. And I enjoy Tetris, so it's always fun to draw the Tetris blocks, so it's a fun puzzle. There you go. I'll see you guys next time.